Welcome to this session. In this session, we give examples on how to determine singularity or singularities of functions. So there are two functions, f of z given by sine of 1 over z, and g of x given by e raised power 1 over z over z squared. So solution. So the first function, f of z, so we say, we know that if you have a function f of z equals to sine z, then it can be written as a series z minus z cubed over 3 factorial plus z power 5 over 5 factorial minus z power 7 over 7 factorial plus other several terms. So this will imply that our given f of z, which is sine of 1 over z, so the role of z here is taken by 1 over z. So this will be given by 1 over z minus 1 over 3 factorial z cubed plus 1 over 5 factorial z power 5 minus 1 over 7 factorial z power 7, and then plus other several terms, and then plus negative 1 power n 1 over 2n plus 1 factorial, and then z is for 2n plus 1. So this is how we write any general nth term for this series. So obviously there is a number of singularity since we know that z sine of 1 over z is not defined or is not analytic at the point z equals to 0. So sine of 1 over z is not analytic at the point z equals to 0, since 1 over z is equals to infinity at z equals to 0. Hence, we have f of z given by sine of 1 over z has a singularity or a singular point at the point z equals to 0. So that's how we solve for the first part. Let's see the g of z function. So part 2, we have been given that g of z is a function e raised power 1 over z divided by z squared. So the trick will be to express e raised power 1 over z as a series. So we know that if we have e raised power z, then this is the same as 1 plus z plus z squared over 2 factorial plus z power 3 over 3 factorial plus z power 4 over 4 factorial plus other several terms. So this implies that e raised to power 1 over z will be given by 1 plus 1 over z plus 1 over 2 factorial z squared plus 1 over 3 factorial z power 3 plus 1 over 4 factorial z power 4 plus up to plus 1 over n factorial z power n plus other several terms. So which this tells us that the g of z, which is given by e raised to power 1 over z squared, this can be written as 1 over z squared times e raised to power 1 over z. So then we write this as 1 over z squared into, so e raised to power 1 over z, we write this series 1 plus 1 over z plus 1 over 2 factorial z squared plus 1 over 3 factorial z power 3 plus 1 over 4 factorial z power 4 plus up to plus 1 over n factorial z power n plus other several terms. And when you simplify this, we get the first term will be, so i.e. our g of z will be 1 over z squared plus 1 over z power 3 plus 1 over 2 factorial z power 4 plus 1 over 3 factorial z power 5 plus 1 over 4 factorial z power 6 plus 1 over n factorial z power n plus 2 plus other several terms. So this, if you take the limit of this function as z approaches 0, you get infinity. So we say here, f of z has infinite number of terms in negative powers of z. So this is the same as what we discussed in case 2. This limit doesn't exist as z approaches 0. So we say hence, actually this is a g of x, hence g of z has essential singularity at z equals to 0, since if you define limit as z approaches 0 of g of z, then this does not exist. So that's an example for that given problem. Now, in the next session, we give more examples on how to find different types of singularities for functions f of z. Thank you.